Okay, so this is part 3 of properties of exponents. Today we're going to be talking about something called a power of a power. I want you to remember the simplest thing that you need to remember is what the definition of an exponent is. And up here in the corner here, I've got x to the third power. Just remember, x to the third power, that 3 means that we're going to have 3 x's. So you can see I expanded that out. X times x 3 times. As long as you have that down, we'll be able to figure out this rule, our next rule here of exponents called power of a power. Okay, so this first example, if I've taken a look at this here, what I have is I have x to the second power, and it's all being raised, that quantity is being raised to the third power. What I'd like to do first is I'd like to look at the outside exponent, that exponent 3, and what that 3 means. That 3 means that I'm going to write this parenthesis 3 times. So I'm going to go ahead and expand this 1, 2, 3 times, and I'm going to copy down whatever is on the inside. On the inside of that, that is x squared. So I have x squared, I have x squared, and I have x squared. The second thing that I want to do is I want to look on each one of these here on the inside. If you take a look at those, each one of those can be represented by 2 x's. And so I can actually expand this even further. If I go on the inside of this and rewrite each one of these with 2 x's on the inside, I'm going to go ahead and expand all 3 of these out. I can ask you, well, if we just take a look at this and we ask ourselves how many of them are there total, we can recognize that this is going to become x to the 1, 2, 3, 4, 5, 6, x to the 6th power. Now you may ask yourself, is there some way for me to be able to go directly from here all the way to the end without doing all of this work? And the answer is yes. What I want to do right now is up here in the corner, I'm going to go ahead and write the general form of a power of a power. So I'm going to have x to the a power, x to the a power, and that whole thing is going to be raised to the b power. So I'm going to go ahead and write this like this. X to the a, that whole quantity is to the b. You will notice here that what I can do with the two numbers is of the two exponents is I can simply multiply them. So if you notice in our example, I have x to the second all to the third. 2 times 3 is actually going to give me 6. And so when we generalize this, x to the a all to the b is going to be x to the a times b. And you can simply multiply these two numbers together. This here is going to be our general form. Okay, so now that we've got the basics down, I want to give you a couple of examples to kind of let you know kind of some different scenarios that you might bump into. This first scenario here, I have 3a to the third power, b to the fourth power. That entire quantity is all to the second power. And what you want to do here in this scenario is if I really think about what this 2 up here does, this 2 would actually ask me to write this thing twice. Now we're going to use the power of a power rule so that we don't have to write this twice. The first thing that we want to recognize is that each one of these, this exponent has to go to each one of these on the inside. So the 2 must go to the 3, the 2 must go to the a, and the 2 also must go to the b. Remember what we're going to do here is we are going to multiply. And so now this is going to become 3 to the second power. We are next going to become a to the 6th power. And then we're also going to have b to the 8th power. powers. What's going to happen? I'm just using this rule of power of a power in which I'm going to multiply the exponents. Don't forget that that 3 actually begins with an exponent of 1. We don't write that down, but we do need to make sure that we remember this. Now I can go ahead and evaluate this. So this 3 squared here is going to become 9. I can go ahead and copy a to the 6th power and b to the 8th power, and that is my answer. Okay, so this next example here that I've got for you is quite complicated. I've got a quotient here going on. It's just a fancy name for a fraction, but I've got this fraction and the entire quantity is all being raised to the 5th power. I always like to tell my students that if you start with a fraction, it's always good to just go ahead and give yourself a fraction bar. That can't ever hurt anything. I'm going to begin by actually going and giving this 5 to the 2. And when I do this, this is going to become actually 2 to the 5th power is what's going to happen. So that exponent is going to be changed to the 5th. Do not write the number 10. This is not 2 times 5. It is 2 to the 5th power. We'll calculate what that value is here in a moment. The next thing that I'm going to do is I'm going to go give the 5 to the 2 on the x squared, and that's going to become x to the 10th power is what's going to happen there. So that's going to be influenced by the 10. The next scenario that we're going to have is the 5 is going to go to the y, and therefore I'm going to have y to the 3 times 5 is going to give me 15. You will also notice here that I have a variable in the denominator, and so I also have to give this 5 to the z down below, and that's going to give me z to the 4 times 5 is going to give me 20. The last step that you need to do most of the time is to be able to deal with this coefficient in front in which you're going to multiply this out. So 2 to the 5th power is going to give you 32, and so this can be simplified to 32 x to the 10th power y to the 15th power, all divided by z to the 20th power, and that will be your answer. Okay, so I hope this video helped you out with the power of a power, and I hope you have a great day.